This one here I consider to be the best one, and this is the one that I break out in parties on Friday nights, say, if I want to impress people, because I think this is really the best way to represent the independent t-test. So we have mean 1 minus mean 2. And often whether mean 1 is smoker or non-smoker is pretty arbitrary. But we just need to specify one mean as the first one and a second mean as the second one. And then we have the variance in the denominator of this formula, variance for the first group, variance for the second group, sample size for the first group, and sample size for the second group. And that's really all you need for the independent t-test in terms of calculating the calculated t-value. Now the bottom portion of the t-test is really where it's at. I mean, this is where the engine room of the t-test is, because the top portion, which is just the first mean minus the second mean, is pretty simple. But it was really the genius of William Gossett who invented the t-test and who devised the standard error of the difference between two means. And that's really where the impressiveness of the independent sample t-test is in that denominator portion. And I'm going to talk a little bit more about trying to understand what this is at the very end of this presentation, so you can have a more gut feel understanding of what the t-test does. So I hope you can persevere all the way to the end so that I can show you something interesting about variances and the independent sample t-test. And what I'm presenting here is that in the formula, usually we don't represent it as M1 and M2. You can, but in textbooks, usually you see it as X bar minus X bar 2. I know it's confusing to see people represent something differently, even though it's the same thing, but it's just the reality of nature right now is that people do that. And X bar 1 minus X bar 2 means the same thing as mean 1 minus mean 2. So let's look at an example in more detail. I want to look at this Brody et al. Study. And I've simulated the data so that we get a result very similar to Brody. So you'll know whether smokers and non-smokers actually have equal brain sizes or not. I know I was interested myself whether that was true or not. So we wanted to know whether smokers and non-smokers have unequal brain sizes. That's framed in the alternative hypothesis way. So the independent variable is smoker versus non-smoker. And what I'd ask somebody right now at this stage is whether you really understand what that independent variable is and that it's actually measured on a nominal scale. Because the independent t-test assumes that your independent variable is measured on a nominal scale. And I know students struggle with that. You really need to understand levels of measurement. I know it's kind of boring, but once you have an understanding of that, you're really halfway to understanding the application of statistics. It's one of the most important things. And so Brody et al. Collected brain volume data using magnetic resonance imaging from 17 non-smokers and 19 smokers. So the two groups, they don't have equal sample sizes, and that's okay for the independent t-test. It works just fine. The dependent variable was brain volume in cubic centimeters, and that level of measurement is ratio. So nominal, ordinal, interval ratio. This is the best, most informative level of measurement. And independent t-test assumes that you have a continuous scale measured on interval and ratio. And that's true in this case. So Brody et al. Actually did conduct a t-test. And he was justified in doing so. So the null hypothesis for this study is that smokers and non-smokers have equal brain volumes. And that's framed in the population as HO mu1 equals mu2. So brain volume for smokers is equal to brain volume in non-smokers at the population level in the whole world, like 7 billion people, whatever the population is that you're interested in. The alternative hypothesis is that smokers and non-smokers have unequal brain volumes. Now stated at the population level, it's mu1 does not equal mu2. Brain volume for smokers does not equal brain volume for non-smokers. So the mechanics